And welcome to our VetCT webinar with Wildlife Vets International. We're delighted to welcome you all today. We'll just leave a couple of minutes for more people to join. But this webinar is part of our anniversary series, and the anniversary of our charity partnership supporting the veterinary input into conservation projects for endangered species around the world. That is the work of Wildlife Vets International. So I'm delighted to be welcoming you all to this fantastic webinar on testing tigers, all about surveillance programs with Jess Bodgener, one of the vets with Wildlife Vets International. So I'm just going to give you a brief introduction if you're not familiar with VetCT about what we do. So we are a veterinary owned company that provides veterinary support services to veterinary teams all over the world in the form of teleradiology, so the remote reporting of CT, X-ray, MRI and nuclear scintigraphy for all species with rapid and reliable turnaround times and a real sort of clinical focus to help support good outcomes for patients. We also provide teleconsulting services, so specialist support to veterinary teams from multidisciplinary team of specialists, so anything from simple case queries to complex case management. We also have an education branch, and we're passionate about education in the veterinary sector, providing both content for veterinary students and services with teaching both veterinary students and radiology residents. And with VetCT, sustainability runs as a real core through all of our projects and our services, helping to support people, animals and the planet. Our partnership with Wildlife Vets International, we did an internal fundraiser last year where we virtually visited their projects all around the globe, which you can see dotted on this map here. So our team collectively travelled over 21,000 miles, stopping off and hearing about the fantastic projects which WVI are involved with along the way, and raising over £7,000 in total. So we're delighted to be continuing that partnership next year and launching some more initiatives in the near future. We're also involved in other projects, so supporting sea turtle rescue and rehabilitation with free access to our services. We partnered with organisations like Vet Sustain and supporting the delivery of veterinary care into conflict zones in the Ukraine and the Royal College of Veterinary Surgeons Refugee Project. So that's enough about VetCT. Just to say that these webinars we're delighted to be putting on for you to enjoy. If you find them fascinating, it'd be great if you either scan the QR code or use the link that will drop into the chat box to actually donate to the work of Wildlife Vets International as a thank you to Jess for her work and the time that she's giving up today, and also to support the work of Wildlife Vets International. So without further ado, I will stop sharing my screen and hand over to Olivia Walter, the Executive Director of WVI, to introduce today's speaker.
Yes, hello. Thank you very much, Liz, and for everybody at VetCT for the opportunity to give this series of talks. I just quickly have a word about WVI. As an organisation, we're very similar to VetCT in that we only work in partnership, and we provide that knowledge and support for vets working on the front line. They tend to be vets working with non-governmental organisations and governmental organisations working in biodiverse countries with endangered species. And we're lucky to work with a number of very good vets, like Jess is one of them, to transfer her knowledge and her expertise into the areas where it's needed most. And I will just point out that this knowledge very often is a two-way process, and our veterinary partners learn as much from our conservation partners as is vice versa. So this month we spoke a few months ago about the wide-reaching consequences of African swine fever. You can see Dr. Linky's talk on VetCT's YouTube channel, and last month Dr. Nick Masters talked about how wildlife health fits into the much bigger One Health picture and influences human health, and why we need to be focused on this holistic idea of health for the whole planet. So this month we're going to focus much more on how wildlife health might be influencing, contributing to human wildlife conflicts, how particular diseases might be affecting the behaviour of animals, And in order to do this, though, we need to survey the health of the wildlife, and that's no mean feat. And doing this on a national scale has many obstacles. So this is what Jess is going to talk about today largely. And she's been involved in surveying tigers, the health of tigers and leopards in Asia for diseases such as canine distemper virus for a number of years now. Jess graduated from Glasgow Vet School, went on to do an MSc in Wild Animal Health at the RVC in ZSL, which is where she met Dr. John Lewis, who is WVI's founder. And together they worked across a number of countries, and sort of prerequisited to the work that you're going to talk about in Indonesia, actually. Anyway, so over to you, Jess. Thank you very much for doing this.
No problem. Right. Okay, right, hopefully that should be displaying properly now. So today's talk is all about testing tigers and the challenges of setting up a sort of a national surveillance program to sort of investigate things. Really the structure of this talk, I'm going to start off with a brief background on canine distemper virus and the significance for big cats in Asia. Then we're going to talk a little bit about the key questions that remain unanswered, a review of the disease progression and clinical signs, just to sort of remind ourselves about distemper, some approaches to testing, and the technical and logistical challenges that are faced when designing and implementing a disease surveillance program. So just a little bit about CDV. So it's a morbillivirus, part of the same family of viruses as things like measles. It has a global distribution, and though it was first described in domestic dogs, most carnivores are now thought to be susceptible. It's highly infectious. It results in a wide range of symptoms, and notably with high levels of morbidity and mortality. Most animals that recover will retain immunity for the rest of their lives. And there have been some significant outbreaks in endangered species, and that's why it's a disease of conservation concern. So there have been outbreaks in the Bale Mountain National Park in 2005 and 2006, and again in 2010, resulting in the loss of several packs of Ethiopian wolves. In 1987, canine distemper virus was implicated in the extinction of black-footed ferrets in the wild. In 1994 and 2001, there were dramatic outbreaks in the Serengeti and Ngorongoro crater that resulted in a third of the lion population dying. And in 94, there were outbreaks in Kenya affecting African wild dogs that resulted in the loss of 20 packs of animals. So what about canine distemper virus in big cats in Asia, because that's kind of what we're here to talk about. So the stories were started back in 2001, and between 2001 and 2010, 5 Amur tigers were diagnosed with canine distemper virus in the Russian Far East. And this coincided with a decline in their local population. A serosurvey conducted in 2012 found antibodies to canine distemper virus in 37% of the tigers they sampled. Following on from this, in 2015, a critically endangered Amur leopard died due to canine distemper virus, and antibodies were detected in 2 other leopards. In 2019, a Malayan tiger died, and further cases have been suspected since then. In 2020, a critically endangered Javan leopard died in Indonesia. And in 2021, a serosurvey in Indonesia found evidence of infection in Sumatran tigers. In 2022, investigations in India identified infection in Bengal tigers and Indian leopards. And in 2023, a serosurvey in Nepal found evidence of exposure in both tigers and leopards. So you can see that the disease really now is quite widespread throughout Asia, and we're seeing cases popping up. It's to some extent new. I mean, in Russia, when they conducted the serosurvey, they found that there were no animals that tested positive before the year 2000. So there was a question mark over whether this was an emergent disease, but it does now seem to be widespread. So what is the significance of this, and what are the key questions that we need to be asking? Well, we know most about this disease in Russia. That's where most of the work has been done. The seroprevalence there is 37%. And if you think about the fact that in tigers, the mortality is estimated to be 30%, for every one animal or two animals that we're seeing testing positive to antibodies, that's correlating to probably another animal that has died and we're no longer seeing at all. The cases that appeared around the sort of 2010 period coincided with a crash in the population. Now, there weren't huge numbers of cases. There were only sort of 5 that were diagnosed, but it raises the question of how many animals are dying without being detected and how many animals are dying as an indirect consequence of those mortalities. An indirect consequence, about what I mean by that is if a tiger dies, for example, as a result of canine distemper virus, and it happens to have 2 cubs with it, then those cubs will likely also die. Similarly, if a male tiger dies, and the male tiger shares his range with 3 female tigers, if a new male tiger moves into that range to take his place, he may well try to kill the cubs of all of those female tigers if they have cubs with them at the time. So there are indirect mortalities that can be associated with it. CDV was also found, they modeled the impact of CDV in the Russian population and found that it increased the 50-year extinction probability to over 50% in sort of small populations. And so that means for small populations of sort of less than 25 animals, if CDV is present, it's more than likely that they would go extinct in the next 50 years. Outside Russia, we know a lot less. So we know that tigers and leopards in multiple countries have been infected and suffered mortalities. But in most countries, we don't know what the rate of exposure is or if the situation is getting worse. We also don't really know where tigers are picking the disease up from. The assumption is often that it's domestic dogs, but that's not always the case. Certainly in Russia, when they looked into it, they found there was very little evidence for infection coming from domestic dogs. And instead, it seemed like mesocarnivores and wildlife were far more likely to be the cause. So just a brief review of sort of infection with canine distemper virus and what that looks like. So the virus is pretty unstable in the environment, so it doesn't last very long. An infection normally occurs by direct contact as a result. Virus particles are inhaled and replicate in the lymph nodes, where they gain entry using SLAM receptors. The virus will then spread throughout the body via the circulatory and lymphatic system, targeting lymphocytes, and this will result in a transient fever and leukopenia. At this stage, the virus may be detectable in the blood, and animals will start to develop antibodies. Some animals will recover at this stage and retain lifelong immunity without showing any other clinical signs. However, if the virus overpowers the immune response, animals will go on to develop further symptoms and into phase 2. So during phase 2 of the infection, the virus gains entry into endothelial cells via a nectin-4 receptor. And that causes a wide range of symptoms, the ones that we sort of are classically aware of. So we see that sort of typical ocular nasal discharge, cough, vomiting, lethargy, anorexia, weight loss, diarrhea. And at this point, we should see the virus being shed in various bodily fluids. Some animals will die at this stage, while others appear to recover. And there's not really a good understanding of why some animals, after being in phase 2 and seeming to recover, then go on to develop neurological signs. It's not particularly well understood even in domestic dogs. But some animals appear to make a full recovery and retain lifelong antibodies, whilst others go on to develop neurological signs. So if the virus has gained access to the central nervous system, it causes demyelinating leukoencephalomyelitis, which produces progressive neurological signs. This results in a change in behavior, loss of fear, blindness, and unresponsiveness. We can also see sort of twitching and seizures and ultimately death. Once animals enter this final phase, infection is invariably fatal. Now, I don't have any footage of tigers with CDV to show you, but I do have some footage from leopards to share. So this first animal you can see is just behaving a bit strangely, not really interacting properly. This one is obviously much more symptomatic. Okay, so there are three main approaches to testing. Obviously, it's something that we want to find out more about. There are serological tests, which are focused on detecting antibodies, molecular tests focusing on detecting virus, and histological screening, which really looks for the pathological changes in the tissues. So the advantage of serological testing is that it can detect past infections. It uses serum, which means that we can test live animals. They don't have to be dead for us to be able to test them. But the disadvantage is it cannot differentiate between an active infection and a past infection. And it also doesn't give us any phylogenetic data. So we can't tell whether the virus that caused the infection in this animal is closely related to the virus that caused the infection in another animal. But it is the best way of assessing population exposure. And just to sort of demonstrate why this is, if we imagine this as a population of tigers, and one of them gets infected, and then it gets better, and then another one gets infected, and it gets better, and then two more get infected, one of them dies, that's sad, another one gets better, two more get infected, and again, one dies and one gets better, and then another animal gets infected. If we were to randomly select say 5 tigers from this population and test them, the chances that we would get a serological positive are relatively high and considerably higher than the chances that we would get a PCR positive. So the chances that we would select the animal that had the active infection. And so when we're dealing with animals like tigers that we're not testing very often, we're not handling very often, and we're really just dealing with opportunistic samples, serology allows us to have a best chance of detecting infection when it's there. Molecular tests, so these, as I said, are focused on detecting the virus, i.e. via PCR. Now, these are really useful if you want to confirm active infections. And unlike serology, they can generate phylogenetic data. So we can find out whether the virus in this animal is closely related to other viruses. But it can't detect past infections. And because the shedding period of canine of the virus is relatively short, you've got quite a narrow window to pick these up. But it is the best way of diagnosing active infections and, determining these from past infections. And then the final way, now this is used, has been used a bit more in the past, but probably not so much moving forwards. And this is histological screening. So we're looking for pathological changes. A big advantage of this is it can be used on tissues that have been archived in formalin. So if you've got a bank of archived tissues, you can use this to go back and test them. But you can only really kind of do this thing on dead animals. Often you're looking at brain samples and things like that. So it's not a sample that you're going to be biopsying from a live animal. The changes that we see are not specific. So you often need immunohistochemistry to confirm your findings. And you can't detect past infections, and there's no phylogenetic data. So if we think back to the cases that we've seen over Asia, these are the ones you can see, they all used serology. These investigations all used PCR, and these ones all used histopathology. So you can see all of the methods have been used and are useful. Okay, so coming back to focus on Indonesia and what we know about Indonesia. So there has been evidence in Indonesia of infection in at least one wild Sumatran tiger. And the reason that I say at least one is that we conducted a sero survey there. But some of the samples that we tested have been collected some time after the animals had been brought into captivity. And so it wasn't possible to say for sure if those animals had acquired infection whilst in captivity or whilst in the wild. But we did have one positive sample that was taken on the day the animal was captured. So we know that animal was exposed in the wild. There's also a confirmed mortality in a Javan leopard and reports of other symptomatic tigers. So both the Javan leopard and Sumatran tiger are critically endangered, and many of the subpopulations are small and highly fragmented. And we know from Russia that that means that they're at increased risk of going extinct in the presence of CDV. We don't have reliable seroprevalences for either species. As I mentioned, we did the work with the Sumatran tiger, but because of when the samples have been collected, it doesn't really give us an accurate picture. And we don't know which species are involved in maintaining the virus in Indonesia. So to try and address this, we decided to come up with a workshop, and that was held in September of 2022. It was led by Forum Harimau Kita, which is Indonesia's sort of NGO that looks after Sumatran tiger, everything related to Sumatran tigers. And it's the first meeting of its kind, sort of national meeting, to really address canine distemper virus in tigers and leopards at a national scale and try and coordinate efforts. The aim was to try and identify strategies to start and answer some of the key questions that I've highlighted, and also design an ongoing surveillance program. We wanted to include as many organisations as we could, ideally everyone who is working with tigers and leopards in Indonesia. And in the end, 32 different organisations were represented, including 5 tiger rescue centres, 7 regional forestry departments, and 6 universities. While the event was led by Forum Harimau Kita, it was also backed by the Indonesian government and Wildlife Vets International. So it was a real sort of communal effort. It was 2.5 days long. The first 1.5 days was sort of presentations, and then we had a day of discussions and development, because we really wanted the surveillance program that came out of it to sort of been developed collectively. So we had lots of breakout groups and sort of people sort of saying how they thought it should go. And one of the slides I think that we shared during that presentation that I think was really useful, just to sort of switch back to those sort of phases of infection, was this, and it just kind of looks at what results you would find at different phases of infection. So you can see during phase 2, in the most active phase of infection, you're probably going to get a positive on your serology, but you may well also get a positive on your PCR. So that looks like a really good time to be sampling these animals. But unfortunately, the difficulty is that tigers are quite like domestic cats, in that when they don't feel very well, what they tend to do is go and hide under an armchair or perhaps a bush if they're in the jungle. So we tend not to see animals presenting at this stage. Sometimes you do, but more often it's when they've reached the neurological phase, and then their abnormal behavior means that they're starting to walk into villages or into towns and encounter people, and that's when they're being picked up. And by the time they've reached that stage, you're far less likely to detect the virus via PCR, because the shedding may well have stopped. And it may well be that at that point in time, the only place the virus is detectable is in the brain, but you will still be able to pick it up via antibodies. So this really sort of highlights the need to really use both serology and PCR in tandem to get the most amount of sort of information from your investigations. Okay, so what were the technical and logistical challenges that we faced in sort of trying to come up with this and design this? So the first thing is, if we're thinking about serology, one of the commonly asked questions we get used is, can we use these sort of commercially available test kits that have been designed for dogs to test tigers? Because that would be great. They're relatively inexpensive. They can be done on a bench side, and yeah, can we use them? Unfortunately, the answer is no. They aren't reliable, and they haven't been designed or validated for this. And just to give you a bit of an explanation about that, because I hate being told I can't use something without understanding the reason why. If we sort of go back to sort of antibody structure, antibodies have a variable region which binds to the antigen or the pathogen or the virus, and a constant region which communicates with the body. And when we're sort of designing these sort of benchtop kits, the way that they work is that there will be some antigen which will be bound to a plate. Antibodies in the sample will then bind to that antigen when the sample is added. This will then become activated, and secondary marker antibodies are then added. And these secondary marker antibodies, in the case of sort of dog distemper test kits, are often anti-dog IgG. The secondary marker antibodies will bind to the activated sample antibodies and become activated themselves. And as part of their activation, they will signal the result. And the way that they do that varies from test kit to test kit. Sometimes they will trigger a change in color, or sometimes they will appear as a line. But that is basically the sort of underlying principle that it makes these tests work. But because the secondary marker antibodies are species specific, the antibody won't bind reliably to a bound tiger antibody. The anti-dog antibody won't bind reliably to the constant region of an anti-tiger antibody in the same way, because it's simply not designed to. It's not part of the same system. And this means that when we get results from these kits, we really can't trust them. And I know I've certainly had feedback from people that said, oh, well, we tried testing them and we got some positive results, so they must work, which is an optimistic way of looking at things. So my colleague, Martin Gilbert, when he was doing his PhD based in Russia, after they tested all of the samples in the laboratory, they also tested them using sort of kits designed for domestic dogs, and they found that the results were really unreliable. They were getting false negatives and false positives. So just because you're getting a positive result doesn't mean the test is working. So currently, the only reliable way of testing for antibodies in big cats is to use a serum neutralization test. This doesn't use a secondary marker antibody, so it isn't species specific, which is great news because it means you can not only use it to test tigers, but you can also use it to test leopards, and you can use it to test other carnivores that you might be sampling and find out a bit more about which other animals have been exposed and where the reservoir for the infection might be. So in this test, what happens is that samples are mixed with live virus before being added to a cell culture, which is then incubated for 3 days. If there are antibodies in that sample, they will bind to the virus and prevent it from infecting the cell culture. If there aren't any antibodies in the sample, then the virus will infect the cell culture, and you'll be able to see the infection in the cells. Now, obviously, this uses cell culture, and it's a lot more demanding and intensive than ELISA methodology. So where those commercial test kits could be done on patient side in your vet clinic, in the jungle if you really wanted to, these serum neutralization tests really require quite specific facilities. So you need to be able to store and hold live virus. You need to be able to maintain cell culture. And it's really a lot better suited to testing in batches due to the work involved, because every time you run a single sample, you have to grow up your cell culture, and it has to be incubated for 3 days. And you're much better off testing a batch of 20 samples, say, rather than testing individual samples as they come in. Now, the good news is that Indonesia does have the capacity to run this test. We worked with a lab there and set that up. But the lab that can do this is in Java and not in Sumatra, which does pose a little bit of a challenge. So what are the other logistical challenges that we have to sort of overcome? Well, we need to sort of raise awareness and ensure that people handling tigers are trained and motivated to collect samples. And I think that's something that the workshop did really well. People were really, really engaged, and everyone sort of took part in the sort of breakout forums. You can see people really contributing, and everyone seemed really motivated going away that they were going to sort of take this forwards. We also need to establish a secure local storage for samples. So that means freezers with backup power supplies. it's probably not surprising that a lot of these rescue centres are quite remote and that their electricity supply might not be the most secure. So we need to sort of think about these things and work these things in. We also need to get the samples from Sumatra to Java. And in order to do that, we'll probably need to put them on a plane or a boat, and we'll need to get specific permission from the government, because we've been moving tiger samples, tiger tissues from one island to the next. So even though it's not leaving the country, you'd still need to get a special permit to move them. And we need to consider the cold chain while we're moving them. So as I said, many rescue centres are fairly remote. We visited one in the run up to this workshop to get an understanding of the conditions, and it was a good day's drive from the nearest airport. So just sort of factoring in how we're going to work those things through. It's also really important to coordinate efforts across all the rescue centres and regional forest offices. So there are only 400 odd tigers left in Indonesia, and a fraction of those get handled every year. If you're in a rescue centre, you might handle 1 or 2 tigers a year, and there's really no point in you trying to conduct surveillance on your own with that limited number of samples. It only really has significant value if we can pool all of that data and start to sort of see a picture across the country. And lastly, I mean, obviously, when you're dealing with lots of different organisations, this can be a tricky thing. We needed to agree on how this programme was going to be funded and how it was going to be reported. So where are we now? Well, a proposed surveillance programme was drafted during the workshop and submitted to the government for consideration. Since the workshop, there has been increased awareness about canine distemper, and rescue centres have been working with their local forest departments to test rescued animals before release. But this is typically, tests are being sent for PCR. So the concern is, I'm going to release this animal, it's either been translocated or it's been rehabilitated, it's now going to be released, and I want to make sure that I'm not releasing disease into the population. Now, while that's a valid thing to be doing, and I definitely don't think we shouldn't be doing that, it is a little bit disappointing that there hasn't been any further serological testing so far. But that's not to say that that couldn't happen in the future. As I've said, the serum neutralization test that we would use is best suited to batch testing, and if samples have been collected for PCR, then it's very possible those samples could also be used for the serological testing. The proposed surveillance programme is yet to be adopted by the government, but to be completely fair to them, they have been quite busy. So Matt talked to us about, there has been this swine fever sort of sweeping across the country. There's a lot going on, and the wheels of government never move particularly quickly. So I think there's certainly time for this to be fully adopted and taken forwards. The good news is that the Ministry of Environment and Forestry already has an existing reporting system. And while it's not currently being used for CDV, the infrastructure is there. So it is something that could be slotted into it in the future. So yeah, that's it. Sort of in a nutshell, all about canine distemper virus and testing in tigers. I know I didn't really talk too much about control strategies or reservoirs or any of those things, but that was largely just because of time. They would probably be individual talks of 20 minutes each on their own. But I'm happy to answer any questions if you have them. And once again, just a reminder that obviously Wildlife Vets International have continued to support work like this and made work like this possible. So if you are in a position to donate and support them today, that would be very much appreciated. Thank you.
Brilliant. Thank you so much, Jess, on behalf of all the attendees and the people that are going to watch it, and for the work you're doing, with Wildlife Vets International. hadn't realised that the numbers of Sumatran tigers were so shockingly low. One question I was going to ask were, you talked about obviously the fact that samples are being taken from just a handful of these tigers by these different sort of remote forestry groups and different organisations working throughout the region, but you know, are these are the samples that are being taken now, could they be stored, and then once a surveillance program does, you know, become agreed at some point, hopefully in the future, could they then be sort of retrospectively looked at?
Absolutely. So that's definitely something that could happen, and in fact that approach has been something that we've utilized both in Indonesia and in Nepal. So in Nepal we tested a bank of archived samples, just like you said, and we're able to look back and sort of pick up infections from the past. The only downside with that is just securing secure storage, basically, and making sure that when you put those samples in the freezer, that they're still going to be okay when you pull them out in 5 years' time, or 10 years' time, depending on how long it takes you to get to that next stage. So the work we did in Indonesia, we were really lucky in many regards, because they had been collecting samples for years and storing them and archiving them. But where we were unlucky was that one of the freezers had gone down at some point in the past, and as a result we had lots of samples from lots of tigers, but as I said, only a few of those samples had been collected immediately after the animals had been captured, and many of the other samples had been collected at subsequent points when the animal had been anesthetized for other reasons. So while they were regularly collecting samples, not all of them survived to the point that they were tested. And that's just something that is just challenging. I mean, it's challenging everywhere, but particularly challenging if your electricity supply is not the most reliable, etc.
Yeah, sure. We've had a couple of sort of related questions coming into the chat from Ian and Patrick. Thanks for those. Just saying, can you tell us if any work has been done to identify the maintenance host species, and sort of related, what other wild species have you found CDV in during your work?
So yes, in the place where the maintenance host species has been most closely investigated is in Russia. So there was a lot of work done there, and that involved sort of a tandem approach, both looking at free-ranging sympatric wildlife, so mesocarnivores predominantly, and also domestic dogs. And what they found in Russia was that there wasn't actually a lot of evidence for dogs maintaining the virus or transmitting it to tigers. They found very low levels of exposure to distemper in dogs. The dog density in the Russian Far East is comparatively low, so not what it might be like in some other places. And it did look a lot more like infection was coming from the wild carnivores. And obviously that makes things a lot more challenging when you're sort of thinking about interventions and how you're going to tackle things, because it would be much simpler if it was all coming from domestic dogs and then you could just vaccinate them with existing vaccines and that would be fine. But unfortunately, that's not the case. In Kenya, after the outbreak in 94 and 2001, they decided to sort of do an intensive vaccination program around the Serengeti National Park, where they vaccinated dogs year on year. And while that reduced the incidence of CDV and really helped with rabies, it wasn't able to eradicate CDV. So definitely in that African context, there seemed to be a mixed picture. So both dogs and wildlife seemed to be contributing. Vaccinating dogs definitely had an impact, but didn't get rid of it altogether. In Nepal, the work that was recently been published out of Nepal, that came out at the start of this year. So in Nepal, we tested both tigers and leopards. So I think we tested 28 tigers and 20 leopards, if I remember rightly. And we found much, much higher exposure in leopards than we found in tigers. And we sort of were thinking about why that might be. And we went back and looked at sort of diet studies that had been done over the years. And we found that there was sort of much higher instance of leopards eating dogs, which has also been well documented elsewhere. There's a lot of work out of India showing leopards eating dogs, whereas tigers didn't seem to be eating dogs as much. And so the seroprevalence in tigers, I think, came out at about 10%, whereas in leopards it was around 33%. So it was a fairly big difference. I mean, in all of these cases, we're working with really small sample sizes because that's just the nature of the game. So it's always really hard to draw, tight conclusions. But I think we probably would find, if we put the time and the work in Nepal, I think we probably would find that dogs are contributing. But I think it would be dangerous to assume that they were the whole picture, because that could lead you down a road where you have spent a lot of money investing in vaccination campaigns and everything else, and then still hadn't really addressed the problem.
And where samples are taken from other wildlife species, with different sort of related projects, whether they're endangered species or sort of related surveillance programs, are they routinely sort of screening for CDV or sort of across different carnivorous species, or does it is there lots more unknowns regarding other wild species affected?
I think there's definitely lots and lots of unknowns, and I think one of the big challenges, I suppose, is integrating veterinary medicine into wider conservation practice, because it's astounding how often people are handling wild animals and not collecting samples from them. And I remember having a conversation years ago with someone who was about to do some collaring of tigers in Indonesia, and they were going to be anesthetizing tigers to place collars on them, catching them, anesthetizing them, collaring them, and they weren't going to be collecting any samples, because to collect samples they actually needed an additional permit on top of that, of the one that they had. And so there are sort of almost barriers in place to people collecting those samples. Whereas I think if you are going to subject the animal to the risk of an anesthetic, the least that you can do is maximize all the information you can get from that event. I almost feel there is a moral duty to be sampling these animals. And I think that probably should be something that becomes more part of, I guess, permit granting and things like that. So when you're designing programs where you are going to be handling wildlife, you're saying, okay, you're handling this wildlife, you're answering this question. How can we maximize this opportunity, and how can we work with other people? That being said, wherever we've worked, we've always reached out to as many people as we could to try and say, well, we're here, and if you've got samples, we're very happy to test them for you. And we definitely would continue to take that approach. But I think the difficulty is often in the first step is whether the samples have been collected, and if they have been collected, whether they've been stored appropriately and securely.
Yeah, well, I think that's a really nice sort of note to end on, just highlighting the importance of veterinary work into these very well-meaning conservation projects, but that could perhaps be looking at things with a broader lens and getting more information about health as well as behaviour patterns, etc. Ty has just added a comment. Great talk, thanks, Jess. So hard getting the programme going, but good to see it's progressing, and hoping the samples come in soon. I think we can all echo that. Fingers crossed there is progress on this. So yeah, just leaves me to say a huge thank you again to Jess and to the work that Wildlife Vets International are doing, and to wish you and the Tiger Project every success for the future. And thank you very much.
Thank you, and thanks for having me today. It's been a real pleasure.
Great, thanks everyone for coming.